Howdy, and welcome to day 15 of our logic curriculum. Today we're going to be reviewing for our second exam. Our second exam covers proving arguments valid or invalid using two-column proofs and truth tables to do that, and also with quantified statements. So let's go ahead and get started on this. So what we're going to be doing is going over the review. Our first part is matching up some terms. So I'm asking if you can recognize several of the arguments that we have. The first three that we have here are the arguments that we remember from page 23. They are the modus ponens argument, where I have a conditional and the antecedent implies the consequent. We've got the modus tollens argument, where a conditional and the negation of a consequent implies the negation of the antecedent. And we have hypothetical syllogism. Hypothetical syllogism is where I have two conditionals where the consequent of the first conditional matches the antecedent of the second conditional, and those middle letters are eliminated, giving us the first antecedent as our new antecedent, the second consequent as our new consequent. We also are just going over some symbols here. So of course we have the conditional symbol, the keywords for conditional or if P then Q. We have the implication symbol, P implies Q. And we have the implication symbol slashed out, that's our P does not imply Q. And then we have a couple of topics from page 11. The idea is that if I have a conditional and I exchange and negate the antecedent and consequent, I have a contrapositive. And also the concept of if I take the two terms of a conjunction or a disjunction and exchange them, I am commuting them, and they have the same logical equivalent property. So this is our commutative property. So we have our first set, which is our matching. The next thing that we're going to do is take a look at proving arguments valid using a truth table. And so in this case we have Tom likes apples or Tom likes oranges. If Tom likes oranges, he'll buy orange juice. Tom didn't buy orange juice. Therefore, Tom likes apples. So for my first premise, I'm looking at Tom likes apples or Tom likes oranges. So I'm going to use A as the statement for apples, O for the statement about oranges, and it's a disjunction because of my keyword or. My second premise deals with if Tom likes oranges, he'll buy orange juice. My keyword here, if, tells me that this is going to be a conditional. O is the letter that we used for liking oranges before, and so we have to use a different letter for buying orange juice. Let's go ahead and call that B. For our third sentence, I see Tom didn't buy orange juice. So this is the negation of the B that we had stated before. And our conclusion is that Tom likes apples, which is what we had for our statement A. So we've listed our premises and conclusions. Now we need to write our argument out. Remember that an argument is an implication. And an implication is a conjunction of premises called a conjunction of statements called premises. So A disjunction O, conjunction O disjunction B, conjunction negation B, and that this conjunction of two or more statements implies another statement called the conclusion. So we have to write this as an implication, but an implication itself is a relationship that's only valid if the resulting conditional is a tautology. So I need to rewrite this as a conditional. That should be O disjunction B. How about O conditional B? O conditional B and negation B. Conditional A is a tautology. And so I need to determine if I actually end up with a tautology. So I've got three different statements here. I've got statement A, I've got statement O, and I've got statement B. Three statements means that I'm going to have 8 rows in my truth table. And half of 8 is 4, so that's 4 truths and 4 falses. For O, half of 4 is 2, so I'll have 2 truths and 2 falses, 2 truths and 2 falses. And half of 2 is 1, so I'll have a true and a false, a true and a false, a true and a false, a true and a false. And I only have one negation to deal with here. I've got negation B. A negation is a statement that has the opposite truth value of a given statement. So this should be false, true, false, true, false, true, false, true. I then need to take care of my two parentheses. I've got A disjunction O, and I have O disjunction B. Conditional B. I will get this right eventually. And of course, the idea here is that a disjunction is a statement that is only false if two statements are both false. And that only happens on the 7th row and 8th row. Those are the only places where these are both false. Everywhere else is true. For O conditional B, a conditional is a statement that is only false if the antecedent is true and the consequent is false. That happens here on the 2nd row, and it also happens on the 6th row. So that means on my 1st, 3rd, 4th, 5th, 7th, and 8th rows, those are true. And so I've got my three premises. This is my premise 1. This is my premise 2. And what I'm supposed to be taking care of here is premise 1 conjunction premise 2. And a conjunction is only true if two given statements are true. That happens on the 1st row, the 3rd row, the 4th row, and the 5th row. Everywhere else is false. And I need to compare this statement with premise 3, again using a conjunction. So it's only true when both of these statements are true, which only happens on the 4th row. So everywhere else is going to be false. And this is going to be the antecedent for my argument. My consequent is A. And remember that a conditional is a statement that is only false if the antecedent is true and the consequent is false. That never happens here. The only time my antecedent is true, my consequent also happens to be true. So I end up with a statement that is a tautology. And this is valid. Remember that if I want to prove an argument valid using a truth table, I have to write the argument out as an implication. I have to rewrite it as a conditional and change it to is a tautology. And I have to use the truth table to prove that I do reach a tautology or I don't reach a tautology. So that's number 9. Problems 10 and 11 are 2-column proof problems. So let's take a look at those. We've set up number 10 as a fill in the blank problem. So my first premise is Jessica likes roses and Jessica likes daffodils. If Jessica likes camellias, then Jessica doesn't like roses. If Jessica likes tulips, then Jessica likes camellias. Therefore, Jessica doesn't like tulips. So I need to write this conclusion out. Jessica doesn't like tulips, and we referred to liking tulips in our third sentence. We use the letter T to represent that. Of course, this is different because Jessica doesn't like tulips, so my conclusion should be negation T. And this is what I ultimately want to reach. So, the first step in a 2-column proof is listing all of our premises. So I've got premise 1, premise 2, and premise 3, which is T conditional C. So after I've listed these premises, I noticed that I saw the keyword and. I have a conjunction in my premise. And the only way that I have to deal with conjunctions when they're already in my premise is the theorem 8a that we talked about on page 23. I'm using theorem 8a on line 1, and when we've talked about this in class, I could use D as well. I can make a separate line for D. I'm not going to do that for 2 reasons. One, because there's no space for it in our proof, and 2, D represents Jessica liking daffodils, which never gets mentioned throughout the rest of the proof. This daffodil information is extra information, and it's not going to help us solve our proof. What I do notice is on step 5, we're putting 2 statements together using a conjunction. That's the second step in the 2-column proof. So this is the conjunction of step 3 and step 2. And I'm doing it in this order because it's important for these letters to match when I start doing hypothetical syllogism. So this uses up statement 3 and 2. And hypothetical syllogism says that I should get the first antecedent and the second consequent, T conditional negation R. And that uses up step 5. Now, when I'm going through this, my fourth step is to repeat until we reach our conclusion. And we clearly don't have negation T by itself yet. So we need to keep going until we reach negation T as its conclusion. And we continue by combining two statements using a conjunction. At this point, I only have two statements, and conditionals always come first. So this is really going to be T conditional negation R and R. That's the conjunction of 6 and 4. And I'm noticing that this is the negation of this statement. And that's a modus tollens relationship. So that's going to give me the negation of my antecedent, which is negation T. And I notice that exactly matches what I have. So that means that we're dealing with a valid argument. Remember, there's a 4-step process for this. Step 1 is we have to list all of our premises. Step 2 is we have to take the conjunction of two statements. Step 3 is we're going to use modus ponens or modus tollens or hypothetical syllogism to simplify. And step 4 is to repeat if necessary. So what I want to do is I want to take a look at problem 11, which is also a 2-column proof. So what I've got here is, if Adam likes video games, he will play them. So I need to write this as a premise. If Adam likes video games, I'll use the letter L. Then he will play them, P. My second premise. He doesn't play video games. That would be negation P. Or disjunction. He doesn't like to listen to rap music. I'll let the letter R represents doesn't like to listen to rap music. And then I see therefore. That's my conclusion. And my conclusion is if Adam likes to listen to rap music, and notice that liking to listen is the opposite of doesn't like to listen, so I end up with negation R. Then he doesn't like video games, so it's going to be conditional negation L. Now, it is really easy to look at this from the standpoint of, well, I see the keyword not. What if I put a negation here? And that's fine as long as there's no negation here. We just need to make sure that we are consistent. So I'm going to rewrite these. L conditional P negation P disjunction R negation R conditional negation L. Remember that we list our statements in the left column and our reasons in the right column. And we start by listing our premises. So I need to list the two premises that we have. L conditional P and negation P disjunction R. And these are both true because they're premises. And in class, we talked about whenever we have a conjunction, we have to use the theorem 8a. Whenever we have a disjunction, we have to use denying the antecedent. So I'm going to quickly use denying the antecedent on step 2. And that's going to change this to a conditional, but only the antecedent changes. So I end up with P conditional R. And that uses up step 2. Now I'm ready to continue. I'm supposed to take the conjunction of two statements, and I only have two statements. The question is, which one do I want? Do I want L conditional P to come first? Or do I want P conditional R to come first? And if I experiment with this, I notice that I want statement 1 to come first and statement 3 to come last. Because if I do it the other way, I notice that these letters here don't match. And I really do want those statements to match. So my statement 4 is going to be the conjunction of statements 1 and 3. So I've got L conditional P conjunction P conditional R. And that is a hypothetical syllogism. step 4. That gives me the first antecedent and the last consequent, so I end up with L conditional R. That's the step 3, where I'm using modus ponens, modus tollens, or hypothetical syllogism. And that uses up steps 1 and step 3 and step 4. So now I'm in a sticky situation. I'm trying to prove something about R and L using a conditional. But I have L conditional R. And I would repeat if necessary, but I don't have any other statements that I could do a conjunction with. So I need to find some way to transform this so it looks like this. Notice that the antecedent and consequent end up being exchanged and negated. And that's one of the logically equivalent statements, the contrapositive. So if I do the contrapositive, that's going to exchange and negate the antecedent and consequent. That uses up step 5, but that also reaches our conclusion. So we are valid. So we can expect a theorem A problem, and we can expect denying the antecedent problem on our next test. The other major topic that this test covers are quantified statements, which we're going to deal with on the next few pages. So I need to write these in symbolic form. So the first thing I need to determine is, are we dealing with universal statements, or am I dealing with existential statements? Universal statements are my keywords are all or none. And existential are going to be using some or not all. So when I'm dealing with all or none situations, I want to use this existential. So when I say all dogs are smart, I'm going to use the universal X. And what I'm really saying is if it's a dog, then it's smart. So that's why we use the conditional whenever we have a universal. I put a predicate for is a dog, X is a dog, and I use the predicate for is smart, X is smart. For number 13, I see the keyword sums, so this means we're dealing with an existential. And I'm saying they are a dog and they eat meat. Remember that existentials are always going to be conjunctions. So I'm saying they are a dog, so my predicate is a dog, X is a dog, and I need someone who eats meat, so my predicate is eats meat, and we're saying that X eats meat. So anytime I've got a universal, I want to use a conditional. Anytime I have an existential, I want to use a conjunction. So let's take a look at number 14. Number 14 says not all dogs are Doberman. Not all means some dogs are not Doberman. And I really need to think of that sentence. As a negation. And I'm not saying that they're not dogs. I'm saying that they're not Dobermans. Again, not all is the same keyword as some, so I need to be using existential X. And because it's existential, I need to use a conjunction. I'm saying that they are dogs. X is a dog. X is not a Doberman, so I need to use negation and some letter for Doberman. Let's use a capital B for Doberman. The actual choice of the capital letter for the premise doesn't matter. What matters, though, is I need to see the existential. I need to see the conjunction. And in the case of 14 as well as 15, I do need to see negation. And remember that my negation always shows up on the second predicate, never shows up on the first predicate. On number 15, I see no. No is all or none. It's a universal, so I'm going to be using universal X. And what I'm saying is if they're a dog, then they don't live on the moon. All dogs don't live on the moon. They are a dog, DX. They just don't live on the moon. Negation in X. So again, anytime I'm using a universal, I want to use a conditional. And anytime I'm using an existential, I want to use a conjunction between my two predicates. On part 4, I'm given the symbols, and I want to write the sentences. So I see existential, and the key word for existential is some. So some what? Some see. Something that is a cat and it is an animal. So I want to say some cats are animals. I realize that the symbol says X is a cat and X is an animal. But I really want to write this in this more condensed form, the form that we use when we're speaking. Some cats are animals. Similarly, for number 17, I want to use the keyword all because it's universal. And I'm starting with F. So all things that are fruit, if it's a thing that's a fruit, then it's an animal. All fruits are animals. And remember that these are statements. I'm not saying that these are true or they're false. I'm just saying that they have a true or false value. So some cats are animals certainly is a true statement. All fruits are animals certainly a false statement. But I'm not asking for the truth value. I'm just asking for the sentence to be written. On problem 18, I see some cats are not orange. Or I could say not all cats are orange. Either one of those is acceptable because that negation either means I need to put not all, or it means I need to negate the second predicate. So that's how we go from symbolic notation to sentences and back for predicate statements. So now we need to actually use these predicate statements, which we'll talk about at the bottom of this page. So it says, write the sentence that is the negation of the given sentence. So what I have here is no ravens are black. No ravens, that's a universal. So I'm saying universal X, they are raven, conditional, they are black. But what I want to do is I want to negate this. And I know that the opposite of a conditional is a conjunction. And the rule is denying the consequence. So Rx stays the same. Negation Bx is what changes. And the opposite of a universal is an existential. So this is what it would look like symbolically. But what I need to think about is what this looks like as a statement. So I want to write this as a sentence. The opposite of all is some. And I'm not saying that they're ravens anymore. Some ravens are, I want the negation of this, not black. And I certainly could say not all ravens are black. That also would work. For the second statement, some pencils are made of wood. This is an existential. I'm saying that they are pencils, and they're made of wood. And I want to negate this. So the opposite of an existential is a universal, all. And the opposite of a conjunction would give me a disjunction, but remember that a disjunction is also a denying the antecedent situation, and that really does get me back to the denying the consequent. So I'm saying they are pencils. All pencils are not made of wood. Remember that for our purposes, the opposite of an existential should give me a universal, which means it should give me a conditional. And the way I get from a conjunction to a conditional through negation is by denying the consequent, not made of wood. Now I certainly can write this as no pencils are made of wood. Either sentence is perfectly acceptable here. For 21, if I want to take the negation of a conjunction, I actually end up with a disjunction. I actually end up with or. And what happens is De Morgan's law allows me to take the negation of a conjunction, and it negates both of these terms. So instead of saying all cats are tigers, I want to say some cats are denying the consequent, not tigers, or the negation of all some dogs are denying the consequent, not beagles. So the negation of a conjunction gives me a disjunction. The negation of a disjunction gets me a conjunction, so I expect to see the word and. I see not all, that's existential. So if I want the opposite of that, I want the universal. All apples are red. And again, because this is existential, if I want the negation of an existential, I end up with the universal all oranges are not yellow. Notice that I had the knot, so it disappeared. There is no knot here. Here I did not have a knot, so I had to put the knot in. So I ended up with all apples are red and all oranges are not yellow. So that's how we write the negations of quantified statements. So the last thing that we need to do is we need to take a look at this from proof standpoints. In other words, given quantified statements, how do we prove something about them? That really is kind of the essence of why we learned them. So over here, we'll just complete these arguments. I'm saying all oranges are edible. So in other words, for all x, if x is an orange, then x is edible. And then I say this fruit is not edible. My subject is this fruit. My predicate is not edible. So this would be negation E, this fruit. And if I have negation E, that really is a modus tollens relationship. It should give me negation O, not an orange. So this fruit is not an orange. For number 24, I'm dealing with no frogs are purple, so I'm doing a universal X is a frog, conditional X is not purple. Because of this no, I need to have negation. Remember that only the second term is negated. In my second sentence, I'm talking about Sally's pet. That's the subject for my predicate is purple. So I've got P, Sally's pet. And so what I need to do is figure out what type of relationship I here. So I need to do the contrapositive. I mean, not the contrapositive. I need to do the modus tollens because I'm got the negation of my consequent. I want to end up with the negation of F. So Sally's pet is not a frog. And so I can use these modus ponens or modus tollens relationships to prove something about these conditionals. And so the last thing I have is the proof where the students have to fill in the blanks. So for problem 25, I've got all cats are white animals. All white animals like sunlight. Fred's pet does not like sunlight. Therefore, Fred's pet is not a cat. So I've got my universal X, CX conditional WX. Got universal X, WX conditional SX. And I've got the negation S, Fred's pet. Fred's pet is the subject. And so the very first thing we need to do is to change statements 1 and statements 2 into, instead of general talking about X, I want to talk about one very, very specific pet. And so this should be Mary's pet. So I want to change this, and the rule for changing this is instantiation. Instantiation takes X and replaces it with Mary's pet. Takes X and replaces it with Mary's pet. So that's what I've got on step 4. Similarly, step 5 is going to change step 2. So step 2, instead of being WX, it's W, Mary's pet. And instead of being SX, it's S, Mary's pet. So this is instantiation. On step 2. And that uses up steps 1 and steps 2, but that also gives me things that match what I've got here with this third premise. Negation S, Mary's pet. And I'm going to put this together with statement 5, because statement 5 deals with S, Mary's pet. So this is the conjunction of statements 5 and 3. And of course, what I'm doing here is I'm using a modus tollens relationship to get the negation of my antecedent. So this is modus tollens on step 6. So this is used up step 5, step 3, and step 6. But this is not my conclusion. I want to reach a conclusion of negation C. So I have to repeat steps 2 and 3. Of course, the only thing that I can put together is I can put together this 4th statement with my 7th statement. So this is the conjunction of statements 4 and 7, which uses up 4, uses up 7. And so I've got C, Mary's pet, conditional W, Mary's pet, conjunction, negation W, Mary's pet. And because this is the opposite of my consequent, get the opposite of my antecedent by modus tollens. So modus tollens on step 8 gets me Mary's pet negation, which is what I want. So this means this is a valid argument. The test that we're going to have on Wednesday covers a lot of material with proving arguments, both as truth tables, but a lot more emphasis is being done on two-column proofs, because that was the major technique that was introduced over the past 2.5 weeks. So there's plenty of practice on the review for the problems a student would expect to see. So I think a student is well prepared if they know how to work every problem on this review. So once again, I want to thank you for watching this video. Have a wonderful day.